Hello and welcome to AspireVision, where we aspire to inspire you with amazing videos on science, technology, health, space and personal growth and motivation. Today we are going to talk about one of the most fascinating and intriguing concepts in science fiction and philosophy of time travel. The idea of being able to visit the past or the future, to witness historical events or to see what lies ahead, has captivated the imagination of many writers, filmmakers and thinkers. But is time travel really possible? And if so, what are the implications and paradoxes of traveling through time? Let's find out. What is time travel? Time travel is the hypothetical activity of moving between different points in time, either backwards or forwards. Time travel can be distinguished from other forms of temporal manipulation, such as slowing down or speeding up the passage of time, or creating alternate timelines or parallel universes. There are two main types of time travel, physical and mental. Physical time travel involves transporting a person or an object from one location and time to another, such as using a machine, a wormhole or a portal. Mental time travel involves sending or receiving information or consciousness across time, such as using telepathy, precognition or retrocognition. How could time travel be possible? There is no definitive answer to whether time travel is possible or not, as different theories and models of physics have different implications and predictions for the nature of time and space. However, some of the most widely accepted and influential theories suggest that time travel may not be impossible, at least in principle. One of these theories is Einstein's theory of relativity, which describes how space and time are interconnected and affected by gravity and motion. According to this theory, time is not a fixed and universal quantity, but rather a relative and flexible one. Time can slow down or speed up depending on how fast an object is moving or how strong a gravitational field it is in. This means that two observers moving at different speeds or in different gravitational fields can experience different rates of time passage, creating a phenomenon known as time dilation. Time dilation implies that traveling at very high speeds or near very massive objects can cause a significant difference in the amount of time elapsed for the traveler compared to a stationary observer. For example, if a spaceship travels near the speed of light, about 300,000 kilometers per second, around a black hole, a collapsed star with an extremely strong gravitational field, the crew inside the spaceship would age much slower than people on Earth. This would effectively allow them to travel into the future relative to Earth. How could time travel be possible? Another theory that suggests time travel may be possible is quantum mechanics, which describes how matter and energy behave at the smallest scales. Quantum mechanics introduces the concept of uncertainty and probability into physics, meaning that events at the quantum level can have multiple possible outcomes that are not determined until they are observed. This also means that quantum particles can exist in superposition of states, where they can have more than one property or location at the same time. Quantum mechanics also predicts the existence of quantum phenomena such as entanglement, tunneling and superposition. Entanglement is when two or more particles share a quantum state and remain connected even when separated by large distances. Tunneling is when a particle passes through a barrier that it normally could not cross. Superposition is when a particle can exist in more than one state or location at the same time. These quantum phenomena could potentially enable some forms of mental time travel, such as sending or receiving information across time using entangled particles or quantum computers. They could also enable some forms of physical time travel, such as creating wormholes, shortcuts through space, or closed time-like curves, paths through space-time that return to their starting point, using superposition or tunneling. What are the implications and paradoxes of time travel? If time travel were possible, it would have profound implications and paradoxes for our understanding of reality, causality and free will. Some of the most common and puzzling questions that arise from the possibility of time travel are: can we change the past? If we could travel back in time and alter historical events, would we create new timelines or overwrite existing ones? Would we erase ourselves from existence or create paradoxes? Can we know the future? If we could travel forward in time and see what lies ahead, would we be able to change our destiny or avoid our fate? Would we create self-fulfilling prophecies or paradoxes? Can we meet ourselves? If we could encounter our past or future selves in different points in time, would we recognize ourselves or interact with ourselves? Would we create paradoxes or inconsistencies? What are the implications and paradoxes of time travel? Some examples of these paradoxes are: the grandfather paradox. This is when a person travels back in time and kills their own grandfather before their parent is born, preventing their own existence. This creates a contradiction. If they never existed, how could they kill their grandfather? The bootstrap paradox. This is when a person or an object travels back in time and becomes the cause of its own existence. For example, a person travels back in time and gives a book to a young writer, who then copies the book and publishes it. The person then obtains the book in the present and travels back in time with it. This creates a loop. Where did the book come from? The predestination paradox. This is when a person travels back in time and becomes part of a historical event that they intended to prevent or change. For example, a person travels back in time to stop a terrorist attack, but ends up being the terrorists themselves. This creates a loop. Who caused the event? How to resolve or avoid these paradoxes? There are different ways to resolve or avoid these paradoxes, such as the multiverse theory. This is when every possible outcome of an event creates a new parallel universe, where each universe has its own history and timeline. This means that traveling back in time and changing the past would not affect the original timeline, but create a new one. The self-consistency principle. This is when the laws of physics prevent any paradoxes from occurring, by ensuring that any actions taken by a time traveler are consistent with the history of the timeline they are in. This means that traveling back in time and changing the past would not be possible, as any attempt would fail or be corrected. The Novikov self-consistency principle. This is when the probability of any event that would create a paradox is zero, by assuming that there is only one consistent timeline. This means that traveling back in time and changing the past would not be possible, as any attempt would be impossible or prevented. Time travel is a fascinating and complex topic that challenges our perception of reality and causality. While there is no definitive proof that time travel is possible or not, there are some theories and evidence that suggest it may be feasible under certain conditions and limitations. However, if time travel were possible, it would also raise many implications and paradoxes that would require careful consideration and resolution. We hope you enjoyed this video and learned something new. If you did, please give us a thumbs up and share this video with your friends. Also, don't forget to subscribe to our channel for more amazing videos on science, technology, health, space and personal growth/motivation. Thank you for watching and see you next time on AspireVision.